Hello, and welcome to OSDR Chats. What do we know about the long-term effects of spaceflight on gestational health? With expectations of longer duration missions with more female space travelers, there's absolutely critical need to understand the impact of spaceflight that extend beyond the mission itself. Today, we're joined by Dr. Afshin Beheshti of the University of Pittsburgh, who will share highlights with us from his publication To Boldly Go Where No MicroRNAs Have Gone Before, Spaceflight Impact on Risk for Small-for-Gestational-Age Infants, and a glimpse into how the analysis working groups contributed to this publication. Thanks for joining us today, Dr. Beheshti. Could you please highlight the most important finding in this study?
Sure. I guess the most important finding of this study is that there can be potential risk of in the female reproductive organ of potential birth defects if a woman wants to come back from space and give birth. We're not talking about birth in space. We're talking about birth after the woman's in space and they come back and then they say, now I want to have a baby. So then if there's long-term effects that carry on from what we show in this paper related to microRNAs, if they are still sustained in the blood, even after, they return and it keeps self-sustained, that means then potentially you might be a risk of having a birth defect. In this case, we're calling it the small gestational fetuses, which means, babies that are born smaller than they should be, than the average weight. And that could cause some babies recover after a time, but some babies who don't. That could cause eventual complications as they grow up because of their initial birth sizes.
Cool. Thanks for sharing those highlights with us and for bringing this area of research forward. My second question for you is, what role did the Open Science Data Repository or the analysis working groups have in enabling this publication?
Yeah, so this work actually evolved from a collaboration and an idea with the NIAID, the National Institute of Aging and Infectious Disease folks at NIH, and the people at NASA. So the idea is, of course, we know OSDR is this great public, resource that anyone can mine, but at NIAID they have their resource called Import, and Import is their version of their own public available database that has lots of nice data related, usually with immunology type, or infectious disease type impact. But they also have other things related with, other kind of biology that was funded by NIAID. So in this case, it was can you merge two different public databases together, that are completely not supposed to be related, right? Space and then infectious disease are related with the, allergy, infectious disease, or NIH related things. People usually don't think of ways of doing that. But if you're creative enough, that's the key. Your creativity. How do we kind of piece these data from all these different resources available for free together? And in this case, what happened was then I started thinking, well, if we see a clinical feature that happens or a feature that happens on Earth that, we see in patients, and so and if this persistent feature is available in this, clinical setting, let's see if it's available in space and happening that way. And if it is, and if it's prolonged that way, that means obviously that risk is associated with that, what people see in the clinic, and then you relate the two data pieces together. So OSDR's facility here was that it provided a data source, that I was looking at microRNAs because, of course, everything I think is microRNA important, or mitochondria, but in this case, microRNAs. And of course, the data set on OSDR that was there, I knew because I've submitted a lot of data and I support open science, and I had submitted a microRNA data set on simulated mice experiments that I did, really simulated space radiation experiments. So then on the import, the NIAID import platform, they have some microRNA sequencing data and other nice available data there. But they had specifically the microRNA data was related with women who gave birth for that birth defect, the SGA, or the small gestational fetuses. And in this case, there was a data set provided by this group out in California where they've done a really nice study where they looked at women at different gestational periods in birth, and then they tracked their microRNAs in the circulation. They said, okay, they found that, they did sequencing, so this data is available. And they were looking at, is there a persistent microRNA signature that could be given during birth to maybe give a hint that a woman might have this birth defect while they're pregnant. So the idea here was to take this microRNA data, see if there's any overlap with the space-related data. And indeed, there was a microRNA signature that was related, that overlap between the clinical setting and space. And now the idea is, well, is indirectly showing that potentially this microRNA signature, if it's circulating in the blood and it's upregulated in space, which in this case it was, it's dysfunctional. Now, if the woman comes back and this microRNA level keeps being sustained, then obviously you're going to have potential risk for this birth defect. And AWG members, this is originally me conceiving this, but then AWG members came along and helped write the paper. That's all a part of the community working together, because I could have just put this paper up by myself, but that's no fun. You need other ideas. Plus, I could be closing my mind of these ideas, but once you bring everyone in and say all the AWG members involved, you'd be like, oh, I got this idea, I got this idea. Like, for example, one of our colleagues, Jean from University of Malta, she's a gynecologist, and her specialty is female reproductive system. She does a lot of research, so she provided a nice angle, which I don't have expertise in, and she does, and she's part of our AWG community. She provided some really nice comments and contribution to the paper related to her expertise in female reproductive systems. So, and then so on. There's other people who provided help and analysis and other things. So, I mean, that's how this project evolved, and how OSDR was instrumental, AWGs was instrumental, but then also now IMPORT, which is the NIAID's resource, another free resource that people can mine, and an example of how you could use a clinical type version of free data and omics available data sets. And it's not just omics on IMPORT, it's everything, just like OSDR does. So ways we combine these two data sets together. Because creativity is your limitation. So let's unlock that in your brain.
Thanks for sharing those insights about the associations that can be made with these databases. I think that's pretty cool, and it really shows connections there. And thanks for sharing your time in general with us, and your insights and your research with us and with our viewers.
Yeah, thank you.
And to our audience out there, you can learn more about this work, how to join the analysis working groups, and access the datasets analyzed in this work with the links provided in the description section below. Thank you and have a wonderful day.